All right, let's just jump right in. Imagine this scene. You're a technician, you're high up on a ladder with your phone out trying to get help from your company's fancy new AI assistant. You need to fix something, and you're looking right at the problem.
So you describe it, right? You give it all the visual details you can, and that is the response you get back. Something totally generic, completely useless. We've all been there with voice assistants, haven't we? That moment of just pure frustration, where it feels like you're talking to a brick wall. But here's the thing. What if the problem isn't that the AI is stupid? What if the problem is something way more fundamental?
Well, it's this simple. Your voice AI is blind. It has no eyes. It literally cannot see what you're seeing. And that's the real reason it's failing. So let's really dig into this core issue, what I call the bandwidth ceiling of voice. Look, this isn't about intelligence. It's about a basic mismatch between how we as humans perceive the world and how a voice-only AI has to hear it. This slide just frames the problem perfectly. Think about it. Our brains process this incredible flood of visual information all at once. Color, shape, depth, context. It's dense, it's parallel, it's instantaneous. But voice? Voice is just a single, slow, sequential stream of words. So when you force a user to describe a complex visual scene, you're putting a massive cognitive load on them. They have to stop what they're doing and become a narrator for the AI. And this, right here, is the engineering problem in a nutshell. You are literally forcing the user to act like a human compression algorithm, translating a rich 3D world into a flat line of text. It's clumsy, it's frustrating, and it's why these systems just fall apart. The answer, obviously, is to give the AI eyes. But the real trick is how to do that without making the whole system grind to a halt. And that brings us to the first part of the solution, building what we call the media plane. This is all about getting that crucial visual information to the AI, but doing it so efficiently that you don't introduce that soul-crushing lag. Now, your first thought might be, easy, just add a video feed. But if you've ever actually tried to build that, you know it's an absolute disaster for any kind of real-time chat. The AI's response time just plummets. So, why is that? Well, the enemy we're fighting has a name.
Yep, the enemy is latency. In a real conversation, every single millisecond matters. High latency doesn't just feel a little slow. It completely shatters the illusion of a conversation. People get frustrated, systems time out, and the whole experience falls apart. So protecting our latency budget has to be our #1 job.
So the secret is to be really smart about the data we're sending. We don't need a high-def movie. We just need enough context. So first, we sample frames intelligently. 1 frame per second is often plenty. Second, we compress that frame right on the user's device before it ever leaves. Third, we merge that tiny bit of visual data with the audio stream. And finally, and this is key, we send it all over a modern protocol like web transport. You can think of it like a dedicated express lane for our data, helping it bypass all the traffic jams of older protocols. It just ensures our data gets there and gets there fast. Okay, so we've solved the speed problem, which is great. But in doing so, we've kind of opened the door to another huge problem, security. And this brings us to the second pillar of our architecture, the control plane. I mean, it's a tempting shortcut, isn't it? Just let the user's browser talk directly to the AI model's API. It seems so much simpler. But I'm telling you, this is one of the most common and most dangerous mistakes you could make when you're building a system for production. Because when you do that, your secret API keys are just sitting there, right in the browser's code for absolutely anyone to find and steal. It's a massive security hole, and it's basically a recipe for someone to abuse your account and run up a gigantic bill. The proper solution is a secure proxy. But let's think bigger than that. This isn't just some simple server. We need to think of it as a dedicated control plane. It's a security checkpoint that stands guard between the user and the AI. It holds all the secrets, it makes sure the user is who they say they are, it validates every single request, and it can even run commands or tool calls for the AI in a totally secure environment. This table really breaks down who does what. The client's job is simple: capture input, pre-process media. The AI model is also simple. It just focuses on understanding vision and language. It's our proxy, our control plane, that handles all the critical stuff in between. It completely isolates and secures all the sensitive parts of the operation. All right, so now we have our two pieces: a super fast, efficient media plane for the data, and a really secure, robust control plane for the logic. So let's see what happens when we put it all together to create a true look and talk experience.
This kind of architecture unlocks some incredible abilities. We're talking frame-level grounding, which means the AI can say, cut that wire, and know exactly which wire you're looking at in that specific moment. It can fuse what it hears with what it sees in real time, it remembers the context from one moment to the next, and most importantly, the whole thing operates in a sub-second feedback loop, which just makes the entire interaction feel totally fluid and natural.
And that right there is the magic. When you really engineer the system to manage latency this carefully, the AI stops feeling like this slow, clunky tool that you're always waiting on. It feels present. It feels like a partner that's right there with you, seeing exactly what you see.
Okay, let's wrap this all up and make sure we walk away with the right mental model for building these kinds of advanced systems. It really comes down to avoiding three very common, very costly mistakes. Mistake number one, thinking you can just prompt your way out of a vision problem. You can't. If the task involves a physical space, you have to give the AI eyes. Voice alone is fundamentally the wrong tool for that job.
Mistake number two, just slapping a full video feed onto your app and hoping for the best. Real-time interaction lives and dies by its latency budget. You have to be disciplined. You have to engineer for speed, not just for perfect picture quality. And mistake number three, the big one, exposing your secret keys to the world. A secure control plane isn't just a nice to have, it is a non-negotiable requirement for any system you expect real people to use safely. And this really brings us to the most important shift in thinking. We have to stop thinking of these things as just chatbots with a camera. That's a toy. The correct mental model here is that we are building complex, distributed, real-time systems, and they demand the exact same engineering rigor you'd apply to a multiplayer video game or a high-frequency trading platform.
So, if you found this breakdown helpful, please share it with other engineers who are trying to solve these kinds of problems. Like this explainer so the algorithm shows it to more people, and of course, subscribe to Lalit Official for more deep dives into production-ready system architecture. We've got a little goal we're trying to hit. We want to reach our first 50 subscribers before February 28th, 2026. If we can get there, I'm going to host a special live session where we can all get together and really geek out on some real-world AI architectures. Thanks so much for watching.